Okay, this is going to be a video of the trig equations, new one for 2023, trig equations day 2. Okay, so what we want to talk about, day 1 we talked about trig equations with one trig function. Today we're going to talk about multiple, and sort of a concept behind multiple. If you've got multiple trig functions, okay, first strategy, I'm going to give you some strategies. First strategy, see if you can take a GCF out and solve, okay? All right, we're gonna talk 2 of those strategies today, all right? So if I can take out a GCF, now what I wanna do, all right, I wanna move everything to one side. So before I do that, what I wanna do to take out a GCF, I wanna move everything to one side. To one side, okay? All right, so what I wanna do here on this, move the 3 cosine back, so it's cosine of x, sine of x, minus 3 cosine of x equals 0, okay? Now, if you notice, all right, both terms have a cosine, so I would take out cosine of x, that would leave me with sine of x minus 3 equals 0, okay? Now, what that allows me to do, solve them individually. Cosine of x equals 0, sine x minus 3 equals 0. So we were in day 1, we did the whole replacement. If you want to replace at the beginning, you can. I'll show you that in a second. Okay, so that would be sine of x equals 3. All right, just like before, we want to find where is cosine 0. Okay, so that would be an axis point. Okay, that would be an axis point, and the place where cosine is 0 are those two. It's pi over 2. And 3 pi over 2, okay? Where is sine of x? Okay, that's 3 over 1 or O over h. Are there any triangles where the O is 3 or the 1 is h? If you divide all those, they don't get. And then around the axis points, they also don't. So that's not going to be an answer. This will be my only answer, okay? Now, if you wanted to at the beginning, if this helps you out, say like A is cosine of x, and let's say B is sine of x. What you could have done is that would have been AB equals 3A, and then move that back over. AB minus 3A equals 0, and you would take out the A, so it'd be B minus 3 equals 0, A equals 0, B minus 3 equals 0, B equals 3. And it would have got to the same point, we would have put the trig functions back in. Cosine of x equals 0, sine of x equals 3. So however you want to do it, sometimes these replacements are easier when you just do the trig function, okay? So move everything to one side, okay? All right, take out the GCF, all right, and then solve the GCF and the thing in parentheses, okay? And then what you're going to do after that is repeat the day 1 stuff. Okay, all right, we find the angle that works, all right, and we just got to consider the positive and negatives for the ratios, okay, all right, so that's one strategy, okay, all right, is sort of to take out the GCF strategy, all right, so like on this one, everything's already moved to one side, so they both have a sine squared, so I'm going to take that out, so that's going to be cosine x minus 1 equaling 0. So I set the GCF equal to 0. I set cosine of x equal to 0. This one, I would take the square root plus or minus. Well, the square root of 0 is sine of x would be 0. Okay, so that would be on the axis points. That would be here and here. So that would be 0 and pi. Okay, this one I move the 1 over. Where's cosine of x equaling 1? All right, the only spot that could happen is right here, which is at 0. Since I already have that, my answers here are just 0 and pi. All right, you don't have to worry about putting the 2 pi there. All right, so go ahead and pause your video, okay, and then go ahead and practice these on your own. And when you're done unpausing, you can see the answer. Okay, so what I would do here is move this sign back. Okay, they both have sine x in common. So it's cosine of x minus 2 equals 0. So I got sine of x equaling 0, cosine of x minus 2 equals 0, cosine of x equaling 2, all right, sine of x equaling 0. Well, where would that have to be? That's the axis points. Those are here and here, so that's 0 and pi, okay? All right, cosine, that's a over h, okay? Well, there's no a of 2 and h of 1, all right? And if I go to the axis points, that doesn't happen. So that would be my only answer, all right? On this one, I would take out the cosine squared. I'm left with sine x minus 1 equaling 0. So cosine squared x equals 0, sine of x minus 1 equaling 0. Take the square root of that, that's cosine x equaling 0. All right, well, where does that happen? On the axis points, that would be here and here. That's pi over 2 and 3 pi over 2. All right, sine of x equaling 1. Well, where would that happen? Where my O over H, okay? Well, there's no triangles, but that would show up here. All right, so that's pi over 2, which I already have that as the answer. So those would be my 2 answers for that one, okay? All right, next thing, next type of situation. Can't do a GCF, all right? Don't have a GCF in here. So here's my next thing I want to do. All right, next like thought process. See if I can substitute an identity or formula, okay? Now, you will have to memorize the identities, okay? All right, but the other formulas you get a sheet for, okay? So what you want to do is, so let's go back. So that's the second strategy, all right? So I've got some identities, and we went over these at the beginning of the last class. Sine squared plus cosine squared equals 1. We got tangent squared plus 1 equals secant squared. And then I got cotangent squared plus 1 equals cosecant squared, all right? Now, we also talked about you want to not only know those, but think about how you would move those. So I could have 1 minus sine squared, okay? I could have sine squared equaling 1 minus cosine squared, all right? I could have this. I could have tangent squared equaling secant squared minus 1. I could have 1 equaling secant squared minus tangent squared. Okay? Same thing here. I could have cotangent squared equaling cosecant squared minus 1. Okay? And then I could have 1 equaling cosecant squared minus cotangent squared. Now, one thing you can try to do, okay? Do I have something that's just cotangent squared? Yeah, I do. I got cotangent squared equaling this. So what I want to do is replace this, all right, with that. So I got cosecant squared minus 1 plus cosecant x equaling 1. So this is potentially a quadratic, okay? Now, if you want to substitute out, now that I'm back to one trig function, cosecant, that's going to be a squared minus 1 plus a equals 1, all right? Bring that 1 back over. I got a squared plus a minus 2 equaling 0. As a factor, that would be a plus 2, a minus 1. I got a equaling, a plus 2 equals 0, a minus 1 equals 0. That would be a equals negative 2, that would be a equals 1. Bring back cosecant. Cosecant of x equaling negative 2 over 1, which is h over o, okay? All right, the triangle that would have an h of 2 and an o of 1 would be the pi over 6 triangle. And since cosecant is negative, that would be quadrants 3 and quadrant 4. So that's 7 pi over 6 and 11 pi over 6. Okay, the other one would be cosecant of x equaling 1. All right, now there's no triangles where the h and o divide and give you 1. But there is an axis point. If you go and look at sine, there's an axis point that gives you that, so that's going to be pi over 2. So all 3 of those would be your answer. Okay, so you might want to write some of these down. We sort of wrote that down already. So you're trying to substitute for that. Okay? All right? Same thing here. Okay? All right? We've got this, okay? And I have an identity that says cosine of x, cosine squared equals 1 minus sine squared. So what I want to do is take that and put that into there. So I got 1 minus sine squared of x minus sine of x minus 1 equals 0. Now, once again, if you want to replace the a with sine of x, okay, so that would be 1 minus a squared minus a minus 1 equals 0. Distribute that, that's 2 minus 2a squared minus a minus 1 equals 0. Now, when you get the negative a squared, go ahead and just move everything back over to the other side. So that would be 2a squared, that would be positive a. 2 minus 1 would be 1. When it moves back over, would be negative 1, okay? So when I go to factor, all right, that's going to be 2a and a. That would be plus 1 minus 1, okay? So I got 2a minus 1 equaling 0. A would be a half. I got a equaling negative 1. Bring back sign. You got sine of x equaling 1 half. That's O over h. I got sine of x equaling negative 1. O over h. Well, the O triangle with 1 and the h of 2 is pi over 6. Okay? Now, since this is positive, sine would be quadrant 1 and quadrant 2. Okay, so quad 1 and quad 2. This one does not have a triangle, but on the axis points, you'll see that that part would give you that answer. Okay? All right, and that's what you would do with that. Okay? So go ahead and try this one, on your own. Okay? All right? Now, what you would know is that this is equal to that. Okay? So what I want to do with this, where this is, so secant squared x minus 1 plus secant x equals 1. Okay, if you want to sub out a for secant, probably a good idea. Okay, so that's a squared minus 1 plus a equals 1. Move the 1 back. That's a squared plus a minus 2 equals 0. Okay, in fact, it could be a plus 2, a minus 1. A plus 2 equals 0. It'd be a equals negative 2. A minus 1 equals 0. A equals 1. Okay? Bring back secant. Secant of x equaling negative 2. That's h over a. All right? Secant of x equaling 1. H over a. All right? Now that one, the h of 2 and the a of 1 would be the pi over 3 triangle. Since this ratio is negative, that puts me in quad 2 and quad 3. So that would be 2 pi over 3 and 4 pi over 3. Okay, there's no triangle that would give me an h of 1 and an a of 1, but if you look at this, this one would. All right, that'd give me a 1, so that'd be a 0. Okay, so that would be my answer. Okay, all right. Now, the last type of these for today, okay, all right, involve these things. This is called a double angle. All right, double angle. All right, now, you get a set of formulas, okay? And if you look at this, okay, the only one, we have a formula that basically says sine of 2 theta is equal to 2 sine theta cosine theta. So that's going to allow me to substitute for that. So I got 2 sine of theta cosine of theta minus sine of theta equals 0. And this is just a GCF problem that we were working earlier, okay? So what I want to do is take out the sine. So that's going to be 2 cosine of theta minus 1 equals 0. Okay? So theta and x are the same thing. Okay? This one, all right, I have to move the 1. That's 2 cosine of theta equals 1. Divide by 2. I got cosine equaling 1 half. Okay? So where is the 0 potentially? The only spots those are going to be is here. So that's 0 and pi. Where is the A1 and the H2? Okay, that's going to be the pi over 3 triangle. And since this is positive, I would be in quad 1 and quad 4. So that's going to be pi over 3 and 5 pi over 3. Okay, all right. Now, when I look at this one, I see sine squared plus cosine of 2 theta. Okay, so the double angle will always trump the other one. Now, what I should do, the preference would be, there's 3 formulas to pick from, all right? I would pick the one that says 1 minus sine squared of theta. Why? Because I want to get to, cosine of 2 theta, okay? I want to get to, 2 cosine squared, okay? I want to get to one trig function. So what this is going to be is sine squared theta plus 1 minus 2 sine squared theta equaling 0. If you want to take out that, you can do a equals sine theta. So what that would be is a squared plus 1 minus 2a squared equals 0. Okay? All right? So if I combine those, that's negative 1a squared plus 1 equals 0. Okay? All right? Move that 1, divide by negative 1. I got a squared equaling 1. Square root of that, plus and minus, square root of 1 is 1. So I got a equals plus and minus 1. So bring back sine. Sine of theta equaling plus and minus 1. Well, that's an O over H. Is there ever that scenario? No, but on the axis points, those would be. So that'd be pi over 2 and 3 pi over 2. So what you want to do is when you substitute that, you want to get something that basically, that quickly, so you can combine like terms, okay? And I think this is the last one I have you doing for today, okay? So go ahead and pause your video. Go ahead, unpause, okay? So what I would have here is, I'd want to put in, there's a formula, 2 cosine squared theta minus 1. I want to get the same thing. So I got 2 cosine squared theta minus 1 plus 4 cosine of theta plus 3 equaling 0. I'm going to replace a with cosine, so it's 2a squared minus 1 plus 4a plus 3 equaling 0. Okay, so that's 2a squared plus 4a plus 2 equals 0. All right, there's a GCF here of 2, so it'd be a squared plus 2a plus 1, which would factor to a plus 1, which that's a 2. 2a plus 1 and a plus 1. Okay, now if I set these parts equal to 0, 2 equals 0, well I can't solve that. A plus 1 equaling 0 and a plus 1 equaling 0. All right, hopefully we know that a equals negative 1, a equals negative 1. Okay, all right, so I put cosine basically back in, cosine of theta equaling negative 1, because it's the same thing. Okay, where is that possible? All right, a over h. Well, there's no triangle that would give me that, but if you look, that cosine is right there at pi. And so that's your answer. Okay, so go ahead, you can practice the problems on your formative, and that should be good for today.